Hello, this is Mrs. Crowley. I'm going to go through an ice table with you, nice and slow. And if you need more help with ice tables, don't hesitate to get in touch with me. Or you can look at the videos that are listed in the module, and there is one there for ice tables. So the given problem is that you are given the Kp value right there, and you are given the pressure of the two reactants, okay? And the question is, what is the concentration or what is the pressure of each substance at equilibrium? Now, as you've already learned, not all reactions go from just reactants to all products, okay? It depends on what the temperature and pressure and volume are. So let's look at this one. So in the ice table, we've got the balanced equation. We want to start with that. So we know that the pressure of the nitrogen is 1 atmosphere. And in ice tables, we either use pressure or concentration. Okay, but this one is going to be just pressure. And we know that the hydrogen is 1.4 atmospheres. Okay, and we have 0 of the ammonia. So that is what we have initially. And we're going to allow this thing to react. So it starts to react. Now, we need to think about what is the change going to be. That's what the C stands for. So we're going to do everything in terms of nitrogen. So this is going to go down by some amount, and let's just call it X. You can call it whatever you want, but it makes sense just to call it 1X. If you want to call it 12X, go ahead, but that's going to muddy the whole system. So if there's a 1 here, just call this 1X. This one, though, has a 3 in front of it, so it's going to go down 3 times as much. And the product is going to go up by twice as much as the nitrogen is going down. Now, we studied that in kinetics. We talked about how things are going to change and what their relationship is. Okay, so at equilibrium then, the nitrogen is going to be 1 minus X. The hydrogen is going to be 1.4 minus 3X. And the ammonia is going to be 2X. So let's talk about how we can figure out what that X value is. So we know that Kp is going to be the pressure of the products raised to the power of their coefficient. Okay, here's the coefficients, right? Okay, so we've got the pressure of the ammonia raised to the power of the coefficient. And underneath, we've got the reactants. It's always in chemistry products over reactants. And we've got the pressure of the hydrogen raised to its coefficient and the pressure of the hydrogen raised to its coefficient. All right. Now, we know what Kp is. We know that it's 4.51 times 10 to the minus 5. So let's fill in then what we've got here. So we've got the ammonia is 2X. Okay, but don't forget, we have to square that. Okay. And the hydrogen is 1 minus X. I should have a 0 there. Let me do that again. 1.0 minus X to the 1 power. We don't really need the 1. And 1.4 minus 3X raised to the 3rd power. Okay, so let's talk about some of these things. Now, here is our Kp. Okay, that's going to tell us a lot about the extent of the completion of this equation. That's what that whole thing means. So let's just say that we take this and we say, well, if we've got 1 atmosphere, and it's only going to change by this amount, okay? Let's just look at that. So that's going to be 0.0000451, okay? So even if we put another sig fig on there, is that 1 going to change at all? No, it's still going to be 1, okay? So we can estimate that those numbers, okay, since they're not, they're much bigger than that KP value, that we can just take the x's out. We can assume that it's not going to change very much, all right? Okay, we want to keep the 2x up there. So subtracting that x from 1 and subtracting 3x from 1.4 is not going to change the value of this x up here very much. So now we can come down here. Okay, so we have 2x squared, 2x times 2x. What is that? Don't forget, it's not 2x squared, it's 4x squared. Okay, so be careful with that. Over 1 times 1.4 cubed. All right, so you should be able then to figure out what x is, okay? And when you do that math, I think x ends up being 0.00556. So it's not going to change too much. All right, now let's go back up to here, okay? So our N2 is 1 minus 0.00556. And that is 0.994 atmospheres. And our hydrogen is 1.4 minus 3x. So 1.4 minus 3 times 0.00556. I think you can do that math. And the NH3 is 2x, or 2 times 0.00556. Okay, so I hope that helps, and if not, get in touch with me so I can do another one with you.